So let's give a warm welcome to Richard coming here and speaking for the next hour on alternative energy partnerships.
It's always evolving, and it's evolving at an exponential pace. That pace is just accelerating year over year. And if you think about, as an example, the cell phones that we all have, probably either in our hands or on the table in front of you in a bag somewhere, hopefully not in your hand texting unless you're taking a photo or something. But we all have this technology. And if we use this cell phone technology as an example, think about how that technology has evolved over time. I remember just from the optical aspect of the cameras. We had these flip phones, and you'd take a picture, and it was terrible, right? It was very novel at the time. No one would ever put one of those in a scrapbook. You could never print the thing out because it was about the size of a postage stamp, and it was very, very pixelated and kind of useless. But as we moved ahead, right, that technology evolved, and the optical technologies got better and better to where some of those cameras are, these phones are taking better pictures than some of my SLRs. And then on top of that, we're adding more cameras. It's like we had one camera on the back, and we got one on the front. I got 3 on the back now. And there's, I don't even know what they're for, but we got cameras everywhere. And so technology is constantly moving forward, and it's fantastic. But at the same time, technology, it's that blessing and that curse, and here's why. As consumers, we love technology, right? The cell phone is a great example. We have more computing power in our hands today than we had certainly 10, 15 years ago, right? And it's always getting better. And as consumers, we want to have that technology available to us. But now think for a moment about our organizations, our companies, and we're trying to keep up with this technology and making sure that we can leverage that technology. And what does that mean for us? And how do we think about technology as a strategy? Because we've got to try and predict where it's going to be in the next 10 years so that we can leverage it and really take advantage of it for our own competitive gain. And so it's always moving. It's a moving target. The second challenge is data. And somebody mentioned, I can't see, so somebody over in this area mentioned they're a data scientist. Data is everywhere. And it's probably tied a lot to the first challenge of technology, right? Let's think again about the cell phone and the cameras there. And I've not done a study on this, but I'm gonna just hypothesize that I bet that the number of photos that everyone has taken in the last 2 to 3 years outnumbers by far all the photos that have been taken in the time frame between the invention of the camera and the ability to upload your selfie into Facebook. I don't know if that's true or not. Somebody could fact check that in the break. But the point is, the technologies tend to generate new forms of data, structured or unstructured. In the case of the camera, certainly it's unstructured data. We have just mounds and mounds of this. And it's not just in cell phones, right? We're also able to measure things that we never thought were actually measurable. I'll give you an example. I can't name the company because I don't remember the company, but there's a company that developed some technology, sensor tech, that they can figure out, like when I sit down, in my car or whatever, they know it's me. It's like butt data. I get in my car and I sit down and hello, Richard, welcome. I'm like, what's this? It's crazy. And who would have thought that would actually be some viable data that people could use? And so the automotive industry is like looking into this and thinking about, that's interesting. Maybe we can capture butt data. I don't know. The point is, though, data it's coming faster and faster and in larger and larger amounts. It's exponential, tied back to technology. And so this challenge with the data is, first of all, in our industry, we already have more data than we know what to do with. We have literally mountains of data. Like we put them in boxes and we send them away because we haven't even digitized half of it. So we have all this historical legacy data. At the same time, we have data coming in from all this new technology, sensors, et cetera. So it's great, but it's terrible at the same time, because how do you keep up? Which leads me then to the third challenge. Talent is another challenge. And I'd say that talent, right, is kind of tied in with the technology and the data as well. And if you think about talent, you might say, well, hang on, Rich. Talent is the one variable that we can control, right? I mean, we can't control the pace of technology. We can control the pace at which we adopt technology or put it on our roadmap for, from a technology strategy perspective. We can limit the amount of data that we want to consume. But talent, we could, just if we have the right people with the right talent and skills in place, they can certainly help us with technology and data. And I say, oh, really? Okay. Well, think about this. Bill Joy, you may have heard, the co-founder of Sun Microsystems, said something along the lines of, it doesn't matter who you are, the smartest people work for someone else. And you think about our industry, we're no longer competing amongst ourselves, right? It was, oh, well, we're all competing for, we're all going to go and compete to try and get, geoscientists and petrophysicists and geologists and engineers. But now we also need to go after technologists, data scientists, data engineers. And guess what? We're competing with the likes of Google, Amazon, Facebook, Home Depot, right? We're competing with everyone in this space for talent. And so what I would suggest is that we need to rethink, reevaluate our talent strategies. Let's look at Bill's quote here. No matter who you are, most of the smartest people work for someone else. What does he mean? Well, part of it is what I just described, right? There's the competition, that space has exploded. Add to that, what are they calling it? The great resignation, right? We're all experiencing it. And that's not just in our industry. Multiple industries are experiencing this because as a result of COVID and people really reflecting on life, they're going elsewhere. And that's just part of the puzzle. Let's think about, for a moment, the world. And I drew this by hand, so don't judge the, incorrectness. It's just, this is the limitations of PowerPoint, okay? But imagine this is all the people in the world, everyone. And on the x-axis there, this is the probability of them being able to assist or solve our challenges relative to technology and data, or any other challenge for that matter. And certainly on the right-hand side, we'd say that that's the population that could help us with a greater probability of success. While on the left-hand side, those folks, not so likely, and everything in between. If you're an engineer at A&M, you're familiar with the bell curve because that's how all the grades kind of got sorted out, and you figured out, oh, this is where I am, right? But now let's think about our organizations again for a moment, and think about our existing talent strategies. And what are some of the things that we hear? I mean, how many of you, or at your organizations, hear things like, our people are our greatest asset. We only hire the best and the brightest. Our ambition is to acquire and retain the best talent possible. And we do, right? I mean, we do. I mean, I'm in this industry, I like to feel that I'm one of the best and the brightest, right? I think we all would argue we're the best and the brightest, for sure. And so if we think about that and we say, well, how did I plot my organization on here? My being mine and yours and yours and yours. How, we all have the best and the brightest. What does that look like? Again, please do not, the data scientists in the room, I know this is not perfect. I couldn't get it to be nice and clean. But I would argue this is kind of how we view ourselves. We say all the people in my company, we handpick the talent to be able to address our challenges in our industry, be it technological or data or in geoscience and geophysics. We do that. And so certainly we have a higher probability of success in finding a solution with the folks in our organization, because look at how skewed that is over to the right? We have more people in our population able to solve our problems, better than all the people in the world. So take your next bite, but make that the bite of reality. Okay, let's get a taste of reality. This is what it really looks like. And I'll tell you guys, this ain't even to scale. Okay, I had to do it like this in hopes that you would be able to see it in the back of the room, because reality is we're a blip. We're a blip on this image. And so, in thinking about that gap, let's see if the pointer works. Can you guys see the gap here? This talent gap, this untapped potential. We think back to what Bill Joy said, all the smartest people don't work for you. They're out there somewhere though. How do we tap into them as an industry? How do we overcome our challenges with technology, data, and talent? Folks, my name is Richard Copsey. I'm an innovation advisor at ExxonMobil, and I believe one of the keys to be able to help us from an innovation and open innovation perspective is through the power of the crowd. So let me level set everyone. I'm sure, because we're the best and the brightest, we already know what this is. But for those of us that are not, you don't have to raise your hand. I'm just going to walk through it, and we'll just kind of go through this quickly so we baseline. Open innovation, something that we've probably been talking about in this conference for the last day and a half. Right? Open innovation, the way I like to think about it is going beyond the walls of the organization to be able to solve our business challenges. That's through collaboration. That's through engaging in the startup ecosystem. That's through collaborating with universities and institutions, organizations like the Department of Energy, for example, right? Thinking a little bit differently, going out beyond our comfort zone. And so if that's the big umbrella that we're playing in today, then let's talk about open talent. You may have heard it as the gig economy. I think they're kind of shifting away from that. So the term gig, I don't know if there's any musicians in here, but that's where it came from. So it's like, I got a gig, and so I'm going to I do my gig, and then I leave. And so this is sort of, the gig economy or the open talent pool is talking about, it's your freelancers, it's your independent contractors, right? We do that. Did anybody take an Uber here? Everyone's like, no, I didn't take Uber. We got one at least. Anyway, gig worker. Another one, somebody backed over my mailbox. I don't know how to fix a mailbox. Thumbtack. I get on Thumbtack, boom, boom, bing. I'm connected. I've got demand. I'm connecting to supply. Gig economy. That's fantastic. And now within the gig economy is what I want to focus on today, and that is crowdsourcing. And so what is crowdsourcing? Essentially, it's competition-based, but it's focused around these communities, and communities that have a very specialized niche. So for example, there are crowd communities that focus on software development, data science, hardware development, CAD, you name it. There's something for everyone. Design. And it tends to lend itself, at least currently, more so in the digital world. And we live in a digital world. So that's crowdsourcing, and it's competition-based, meaning almost like bounty hunters. It's like I put the bounty out there, And then people will go and try to solve that challenge, either individually or as a team for some sort of prize. It doesn't always have to be monetary, but it typically is. And that's crowdsourcing in a nutshell. So let's think about the value case for crowdsourcing. Why do I think that this is a valuable proposition for us to consider in our industry? Well, first of all, crowdsourcing, in my opinion and in my experience, it enhances the way that we execute and operate. And it does that while maintaining a relatively small footprint. We can maintain our existing footprint, and footprint I'm talking about headcount, right? We maintain a small footprint, but being able to get exponential resource from that. So from crowdsourcing, we're able to access talent on demand. Who doesn't like everybody here, tell me if you like Netflix. This is a dead room. I can at least see hands that go up. I was like, all right, who's reading the Journal of Petroleum Engineering? Not even a hand went up for that. Jeez, okay. But we understand what we mean by on demand. Now think about being able to turn on and off access to resources, access to talent as you need it, when you need it. And more importantly, and I should have bolded the second part of this, because this is where I think the magic happens. Diversity and inclusion. There is nothing more diverse nor inclusive than this approach. Why? Because I'm not paying people based on what their last name is, based on their address. There's no way that any unconscious bias can enter into this transaction, because I just care about the results. You deliver, I like it, you're cool, I pay you, we go on. And that unlocks an entire new way of thinking in terms of, I don't know if we have any HR recruiters in here, but this is a pretty fantastic way to get to resources that we would never touch in a million years. Why? Because remember, we hire the best and the brightest, and we're all competing, and we're all going to the top tier universities. So we're going to the Stanfords and the Yales and the Harvards and the Texas A&Ms and the Rice. But we're not going to random places in Southeast Asia. More and more folks are educating themselves on their own based on passion. Khan Academy. Certifications mean nothing. We use that we hope to mitigate our risk when we access talent. Like, oh, you're Microsoft certified, fantastic. That's great. We know he can do it. No, we don't know that they can do it. They just got the certificate. We don't know. Some people just test well. I test terribly. And so, this helps us access talent that we would never have access to any other way, because our existing paradigm is broken. And by the way, those competitors, they're not really doing this very well either. Some are, but we won't get into that. The other part of crowdsourcing is that it's extremely time and cost efficient. And I'll show you a little bit of that, in some of these examples. But if you think about our normal way of doing things, it's very horizontal, right? Maybe I should turn this way. Horizontal. Because we start over here with an idea or an opportunity, and then we make a decision to pursue that opportunity based on some sort of criteria to make an investment. And then we're going to test, we're going to build, we're going to have some sort of hypothesis, critical assumptions, if you will, and we're going to be testing those iteratively. And we do the agile thing, right? It was like build, test, measure, build, test, measure, build, test, and we keep doing it, right? And then we're trying to prove or disprove our hypothesis until we arrive at a minimum viable product, minimum viable solution, whatever, fill in the blank, minimum viable X, before we then scale. That's how we do things. That's great. How much time did it take us to iterate over time? With crowdsourcing, what you're doing is you're turning this horizontal approach to delivering value, and you're turning it vertical. You're testing multiple hypotheses at once, in parallel. That means shortening the time to value. You can disprove things faster. Time is money, right? The sooner we get to market, the competitive advantage before everyone else figures it out. Crowdsourcing offers a much higher probability of arriving at a successful outcome. And not only that, a higher probability of getting a novel or new or unique or innovative solution as well. And why is that? Well, I don't know, I can't see anyone, but if there's any soccer fans out there and you watch the Euro Cup, right, it's more shots on goal, right? More shots on goal equals more balls in the back of the net. Forza Italia. I'll just leave it at that. If you watch it, you know what I'm talking about. More shots on goal, greater probability. It's a numbers game, right? Where'd my data scientist go? Did she leave? Wow. More shots on goal, greater probability of success, more novel solutions. And the last piece here, which is critical to that last discussion, when we talk about, we got a talent problem. We got a talent problem beyond what I just talked about in terms of competing and trying to fill the gap. We got people leaving. We got people poaching our folks from other industries because they know they're the best and the brightest. And we have these talent strategies. And so imagine we think about our capabilities, our core competencies in our organization, and we have some that we say are their competitive advantage. There are some of our capabilities that make us unique. It's all probably different for all of us. Some of them are probably the same. And then there are some capabilities that are just commodity. They're commodity. It's not that they're not important, they're just commodity. And so if we're trying to get to a talent strategy to be able to compete, not only in our industry, but in all industries, we need a way to augment our talent. And what crowdsourcing offers is a way to fill the gap. So you could essentially, let's say I'm trying to build up my data science capability, and we're just getting started. I know everybody's got one now, but let's say that you didn't. We were like, oh, we need to hire 50 data scientists. Go to Berkeley. Go to A&M and find the best data scientists you can find, and we're gonna knock this thing out of the park. And I'd say, hang on. Why not find 2 or 3 very highly skilled individuals that understand your business, understand data science, and can be kind of the catalyst and help you build that team over time towards your strategic objective, and you augment that with crowdsourcing. So you're filling the gaps as you go. And oh, by the way, you might even discover some talent from the crowd while you're going there. So this is kind of my case for crowdsourcing. And this is all me just talking. Let's talk, I'm going to build upon this, why I think it's better. This is my talent triangle. So in this talent triangle, right, we have some various, I don't know what you call them, domains or aspects. And we have costs over here on the left, right? So typically, our employees are going to be the most expensive assets that we have. And that's okay. We want to retain them, right? And then you would argue, and let's just put this in perspective. Let's say it's, on a long-term basis, because certainly I would argue, well, my contractors and my consultants are less expensive than my employee. Well, maybe, but in the long term, in the grand scheme of things, they're going to be less expensive than our employees. And then you could probably bucket the gig worker or freelancer in there with the consultant or contractor, but then the crowd is going to be the least expensive option, I promise you, hands down. And if we think about the time to value, the time it takes to deliver value, I already kind of mentioned my going vertical. You could, this might be a sensitive subject. I'll say it this way. It would be this is a logarithmic scale. So, but in reality, what would happen is employees, contractors, and gig workers, more than likely, are all going to be able to deliver value in a relatively similar time frame. Whereas the crowd is going to be way faster. I mean, way faster. And then it's a triangle and not a rectangle because at the bottom here, trying to illustrate access to skills and talent, the breadth of talent. And so again, we hire the best and the brightest. We hire the best and the brightest to solve our existing known problems and working towards our core competencies. And therefore, that employee width is going to be relatively narrow, right? We have our own niche. And that's okay. Because what we do then is if we're kind of venturing off into a space that we're not that familiar with, what do? We say, hey, McKinsey, Deloitte, BCG, you guys, can you send somebody over here? We want to start this digital transformation thing. Yeah, that'd be great. Send your guys and we'll have a conversation. Then they kind of help us and they augment our talent in that way so that we can learn and then we can take it and move forward. And same with the gig worker, right? Same sort of thing. It's augmenting our existing capabilities. But the crowd blows that out of the water. Because remember the big bell curve? That's the crowd. So this is why I think it's better. Let's talk about a little bit more tactically, how does this actually work? And what I'll do is we'll talk through first, how do we traditionally deliver value in our existing paradigm relative to then how we do it with the crowd approach. Again, excuse my animations. I never worked for Pixar, so traditionally, this is what happens. We have a problem or a challenge. We give that challenge to one of our people, or maybe a team, right? And they work on it, work on it. Then we get to a result. And the result there, I don't know what color it looks like to you. To me, it's kind of a bluish green, maybe aqua-ish. That indicates positive outcome, successful result. And that's why the little person on the end is like, hooray, we did it, right? Awesome. Gold star. Well, there's nothing on here about time. And there's nothing on here about quality. I'm just saying you met the objective. So now let's contrast that with the crowd approach, where I'm taking that same problem that I'm trying to solve. And instead of creating this one-to-one relationship between problem and solver, I'm creating a one-to-many relationship. Remember the shots on goal? These are my shots on goal. Like, tell me a goalkeeper that can block 10 shots being knocked at them simultaneously. Not going to happen. And so you can see here in this situation, of the 10 people that took on this challenge of mine, remember the greenish blue is success. So 7 of them were successful. They delivered a positive outcome. 2 of which they delivered something, I'd say it was caca. It wasn't good. Like, sorry. Like A for effort. And then the little question mark would be like my 13-year-old son who's like, I'll try it, but I can't be bothered, right? So that person just didn't even do anything. And it's okay. I'm only paying 1, maybe 2, maybe 3, depending on the situation. But I certainly am not paying all 10, and I'm certainly not paying all 7 that were successful. And now think about the way that we're supposed to do things, right? From a project perspective, or if we're building a digital solution, what do we always say? Amazon does the whole, do the press release up front and then build from that. Well, that's tied to identifying your critical success metrics. And so imagine now we actually did, develop some critical success metrics. We need some sort of rubric to figure out who from the crowd am I going to pay? And if we did that for all of our projects, internal or crowd, I think we'd all be in a better place. I don't think that we do that, but in any case, for the crowd, you have to, it doesn't work. So you have a rubric for what good looks like, and then you're able to kind of create this seriatim ranking of the solutions, of the outcomes. And so now I can say, okay, well, of the 7 that were successful, I know this one was better than this one and that one, right? And so I pay number one, and oh, my little guy is now not saying yay at the top there, because that solution, relative to the same rubric, was good, right? Second place, but it wasn't the best. And what's the probability of that happening? If I have, this is with 10 people, imagine I had 100 people, 600 people working on a problem relative to what we would do internally. I don't know, what's the probability of the crowd delivering a better outcome than we would deliver internally? Probably pretty good. Which then leads me to my segue. So there's a study done by MIT. And what they discovered was that the solvers, the people in the crowd, right, were more successful when they actually had less experience in the domain or discipline with which the problem was within. Why is that? No assumptions, no existing paradigm, right? We live in an echo chamber. We're all geoscientists, and we all do our geoscience the same way, right? And we have approaches in our company, and we do it a certain way. People always say, well, we need to think outside the box. Well, why don't you just get somebody that's outside the box to do the thinking, right? And so the next question would be, well, okay, so thank you for that wisdom, Rich. How would I then do that? How would I open the aperture, cast a wider net to get more solvers that are not just in my domain? You know, if I put a problem out there that is very geoscience focused, chances are it's only going to attract people from the crowd that are familiar with geoscience. So let's look at this example of a potato chip. I don't know, COVID did a number on me. I could barely fit in these pants. So I mean, the potato chips are not my thing anymore. They were definitely for the last 6 months. But let's look at this example with potato chips, right? And so this potato chip manufacturer, let's say, you know, they got this problem. Customers are complaining because the chips are too greasy. Like, I eat it, and then it's like, this is too greasy. I don't want to buy these chips anymore. So they're like, well, what do we do? One guy's like, well, I remember in middle school, whenever they brought out the pizza, you know, we would take a napkin and we'd set it on there. We'd let it sit until the napkin went clear, and then we'd take it off and like, ta-da, no more grease on my pizza. They tried that, I'm sure. Didn't work. Breaking chips. Not cost effective. I mean, paper towels on chips ain't gonna work. So now imagine you rethink, right? You gain diversity by generalizing the problem. And so if we take this same example and we say, all right, instead of removing grease from a potato chip, let's say, how might we remove a viscous fluid from a delicate wafer? It's the same, right? It's the same. But it's just a little bit different. This is a real case, by the way. And it was solved. And I'll tell you how it was solved. So this goes out like this with the viscous fluid, delicate wafer jargon, and probably some more verbiage around it. But there was a young lady who's a professional violinist. And one day she's like, doing her thing. And she's like, every time I play, I see dust jumping off of my sweater or off of my violin itself. Maybe, hypothesis, could you perhaps resonate these delicate wafers at a certain frequency by which this viscous fluid would just jump off like the dust did on my violin and my blouse? And guess what? It worked. Solutions from unlikely places. And the only way you get that is by really opening the aperture and thinking about problems in a different way. It's an art. It really is. Because at the end of the day, when we're talking about, you know, some of our petrophysical problems, what is it? The nuts and bolts of it. There's math, right? There's physics, maybe some spatial analytics. If you can break those pieces up I mean, I was in the military. When you talk about top secret information, we have this thing where it's like you compartmentalize information. And you can do the same thing here. You can take a big problem and you can break it into parts. One, it's good for if you want to maintain some sort of IP or competitive advantage. You don't want to give it all away, and you're solving little pieces here and there. But it also helps in this situation to kind of open the aperture and get more people involved in what is it you're trying to do. So this is all good, right? Now, I can't see your faces very well. I'm going to assume you guys are like, okay, this guy's been droning on for how long? 37 minutes. Somebody get him off the stage, or have him show me the money and how this actually works. So let's talk about crowdsourcing for real. Here's one from Harvard Medical School. This is an interesting one. So Harvard Medical School had an hypothesis. They said, hey, I wonder if it's possible to build an algorithm that automatically, using computer vision, can identify, detect, and outline tumors from CT scans. And of course, and they did. They were able to do that. They were able to do that in 10 weeks. They were able to do that in 10 weeks and $55,000. They had close to 600 people participating from 62 countries around the globe. And they solved it. In fact, the model, and the reason why they have 7 winners, by the way, typically it's like 1, 2, or 3, but the reason why they have 7 winners is if you read in the solution, it says the winning solution was an ensemble model. So they essentially took multiple of these winners, had slightly different approaches that when they brought them together actually made the model even better. 10 weeks, 55 grand. Does anybody have that in their budget? No one's raising their hand. No one wants to reveal their budget. It's okay. Let's talk about some friends of ours just down the road, NASA. NASA is fantastic, and they do this all the time. So I picked one, but they got like 50. And if you want an introduction, Steve Rader, who leads this group down there, is fantastic, and he'd be open to discussing. But this is one of theirs. So you got this situation where our astronauts are out there, and they do these walkabouts, or what do you call it? They go outside and they walk. And they don't want them to get this really nasty sunburn from a solar flare, because this is bad news, apparently. I've never been, I don't know. But they wanted to figure out, they already had their existing algorithm. The question was, could it be improved? So let's put that out to the crowd and see what the crowd can come up with. Again, look at this one. They had a first place winner and a second place winner, $30,000, 165 days. What is that? Somebody, a math wizard? In months? It's like 5.5. 5.5 months. And that's all well good, right? They actually, the model you can see here was improved. They were able to get 8 hours notice with 85% accuracy. It's a safety thing, right? It's important. But the coolest thing is here in green, the winning solution came from a retired radio frequency engineer. I don't know what a radio frequency engineer is, but the fact that this person was retired means they were probably playing golf, but they had a lot of knowledge in here. And they saw this come across like, I can solve this. And they solved it with ground-based data. So not even NASA with its mounds and mounds of data that they have from space, right? They did it, he or she did this with ground-based data that's accessible to all of us. It's awesome. Let's look at one more. I don't know how many of I know some of us, somebody mentioned research and development. So here's Roche Diagnostics and their research and development. I don't have a lot of the details on this one because I couldn't find more than what I have here on the slide. But essentially, they were trying to figure out a way for 15 years to get a more precise measurement of sample quality and quantity. Sample of what? I don't know. It doesn't matter. But the result is amazing, because for $20,000 and 6 weeks later, not only did they find a solution to this problem that had been plaguing them for 15 years, but they also realized all of the non-winning solutions replicated every single thing that they had tried for the past 15 years. Now, I don't know about you, I'd be like, oh, like I've been working on this for 15 years and these guys did this in 6 weeks. But that part of it aside, think back again, going from horizontal to vertical. Imagine what that means to our research and development entities within our organizations if we can say, if we have guided research and we're testing our hypotheses at scale for nothing. I hear whispers, and it must be because you guys are excited. So all that is like outside of the industry, right? None of that was oil and gas. And so some of you may still be skeptical. And I'll tell you, I certainly was too. When I was brought into Anadarko, they said, hey, we want you to come over and be our open innovation manager, and we want you to do this thing called Crowd. And I was like, Crowd what? No, I don't know about this. And they told me what it does, and I was like, seriously? Okay, this sounds like smoke and mirrors, a little David Copperfield going on. I don't buy it. So I dug in. And then I was like, holy moly. This stuff works. If you do it right, and if you think about it the right way. A lot of us have tried this out. I know I'm not going to name names or companies, but we've tried it out, and it didn't work. I will argue we didn't do it appropriately. You might need a bit of a Sherpa to get you started, but once you figure it out, you're off to the races. So what I have here, this is slightly outdated, because Anadarko doesn't exist anymore, at least not in its former glory. It's now more glorious. But if you think about this, look at the top one here. Accessed more than 2,000 unique individuals across 90 countries. To put that into perspective, at the time, Anadarko had 4,500 full-time employees. Little old me and my band of 4 were accessing over 2,000 people for my efforts. That's cool. And you want to if people are like, well, what about the cost aspect of it, and how long is it, how fast is it? So these are averages. I know averages are kind of not the ideal measure. So I didn't give you the mean and the median and the mode, but on average, we were solving challenges in about a week. When I say challenge, what I was doing was taking that big problem, breaking it up into smaller pieces, and those are challenges. So I was incrementally delivering, which is why I have over 300 challenges. So if you're good at math, you say, well, so it costs you about $2,000 average per challenge. You did over 300, so that's like $600,000. Like, yeah, $600,000 over a year and a half, almost 2 years. And how many? I mean, that's nothing. That might be, you know, depending on whatever your blended rate is, that could be 3 to 5 FTE. But we delivered results. And so the last little 3 boxes I won't go into because I'm actually going to talk about them now, depending on when I get the hook, which is in about 15 minutes. I thought it was going to be faster than this. My slides suck, so I'm not like, and I also was like running out of steam when I was building these, so they're not going to be like the most snazzy as the ones I had earlier because I've been delivering those ones for a long time. But if you look at this here, we had a challenge, and at the time, there was no way to automatically detect faults. And so we thought, well, let's see if the crowd can do something. Let's use some computer vision and see what they can do. And so this is actual results from what they were doing. And you can see they did this thing where they, I mean, and I'm assuming there's a lot of geo people in this room. I'm not. I'm a business guy and a data scientist. But essentially, they were able to find and expand wherever intersections were, highlight those to make them more visible, and then looking at wherever these known groups were and expanding on those to kind of identify new groups. Now, the moral of this story is, in 160 days and $8,000, they didn't deliver anything. They delivered what you see on the screen. But that's okay. Because what happened was our internal team of data scientists that had been working on this for a while were like, well, that's an interesting approach. We had not thought about that. We're moving ahead. Let's take a little bit of that. Let's move it in here. Boom, and we just keep going. And they were able to successfully deliver their product. for an auto fault prediction algorithm. So it was a catalyst for things. So it's not always going to be that ultimate solution. This is my favorite one, and I don't think I'm going to have time to talk about it. But I'm assuming, I know I met, was it Tom? There's Tom. You guys know what this is? Does anybody know what this is? You know what that is? Holy moly. This is a modern, this, I don't even think they make printers for this anymore. Like that printer, I haven't seen one of those since the early 90s. Mud logs, sometimes 150 feet of information, been around forever in our industry. And a lot of that data is free, or access to those is free. We had a hypothesis. It was like, look, all the modern mud logs, which you can see on the screen, which is very pretty and very easy to scan in and extract data to turn it into structured data, is not what I gave to the crowd. I gave to the crowd 10,000 mud logs that were very vintage. Some of them were discolored, handwritten. Some of them were they were sat on in a truck with some coffee and were then photocopied of a scan. I mean, they were nasty. But they were at least typewritten. I mean, handwritten ones would be way too complex for this first try, but they were still somewhat legible. And the question was, can you guys, crowd, help us figure out a way to extract these remarks, this information here? Because this is the only time geologists can really get their eyes down hole and understand what is happening down there. Right? Everything else up until that point is kind of like conjecture. But when as they're drilling and the clippings are coming up, they're taking these clippings and they're going over and they're, sniffing them. And I've heard that geologists, you guys lick rocks too. Okay, fine. But they're trying to figure out all the characteristics within those clippings at that depth. And they're looking for things like scat and pyrite and presence of petroleum, all these different things. Fluorescence, fluoride. But when they're looking to kind of use that data for their decision making, they can only go through 2, maybe 3. Because the vintage ones, the older ones, are very difficult to scroll through, even if it's scanned into a PDF. So what the crowd was able to do for us is clean up the data, convert it into structured data with depth registry. And they did it with, the first round was about 80% accuracy, which is still pretty good, considering I gave them the worst of the worst mud logs. I had geologists banging on my door saying, I want this data, man. I said, it's only 10,000 mud logs. No, but it's in a relevant area. And I gave them not a CVS file, a CSV file, right? And they threw that thing into Spotfire and they're like, wait a second. I can see, if I ask the question, show me all logs with the presence of pyrite or whatever of this vintage in this area and between these depths. And there was more and more desire for that. So I thought, well, we're onto something. Let's expand this. We expanded it to 60,000 mud logs, scanned in, now structured data, and then we built a product to help make that a little bit easier for them to consume. So one, they're not knocking on my door asking for an Excel file. It's just there readily available, and they can easily kind of do the searching that they need to do. Now, I'd say it saved us 50 plus years if I were to have 2 geologists go through all 60,000 of these one by one and try and capture all this data by hand. So clearly it's indirect data, soft benefits, improved decision making. I can't tell you how much a mud log goes into an interpretation. That'd be a very difficult question to answer. But it's there. It contributes to the speediness. So I love this one. And you can see it was $100,000. It took us over a year, but we delivered a product. And $100,000 is nothing. The biggest prize I think I paid for a single challenge was about $5,000. This last one, I don't know how many operators we have in here in the Delaware Basin. You may be a customer. So we had a production engineer in the Delaware Basin, and he's like, man, you know, we're trying to coordinate amongst all the operators, but it's so like heavy lift, right? We're sending spreadsheets and all this stuff out all over the place, and it's just not up to date, not clear. And so we thought, well, let's build something for, you know, using the crowd, and you work with the various operators, build something together that allows them to upload in a standardized format your fracking schedules. Because frac hits are bad. They're not good. You know, producing oil and water and gas is okay. When you start producing sand, it does a number on your equipment. And it can get extremely costly. So in 112 days, we built this web application that helps capture all this information and contacts. And then we decided, you know what, this is not an Anadarko thing. We shouldn't be managing this. So we gave it to a third party for free. And we said, you have to then make it available for free. So that's hopefully provides a little bit more relevance in our space. The last thing, it's not all going to be rainbows, sunshine, and apple pie. It's not always going to work. And there's all these roadblocks. If you try to do this in your organization, you know, procurement's going to be like, Legal's going to be, woo, what's going on here? IT is going to be like, what? This is my space. Let alone data scientists. And she left me. I don't know where she went. So not every challenge is appropriate for this approach, certainly. But that's true of many, many things. But don't let the roadblock of being resistant to change prevent you from thinking about an approach like this to help us in terms of overcoming our technological, our data, and our talent problem. Think about this as a way to augment our existing capabilities and move forward. Let's innovate together. And that's all I got, guys.